Okay, welcome everybody for the Aerial Robotics Community Group for a presentation meeting on March 27th, 2024. So we're going to have a nice presentation by Rhys today about Gazebo and Aerial Vehicles. Going to present a nice overview, but before we're going to go into that, I have just a couple of announcements that we would like to share first. And after, of course, once Rhys has his presentation, there will also be some time for questions for that. And then, of course, the next meeting details will be shared as well. So let's go into announcements. It's a bit similar to the announcements I had last time, but it would be nice to kind of still have a nice, let's say, headlines for them. Because last development meeting, we presented like 2 new subcommittees, which we had next to like the outdoor navigation subcommittees that we have in Aerial Robotics Community Group, which is indoor navigation and simulation. There's currently 2 discourse threads going on to talk about what kind of development goals can be done within these fields of topics. We had quite some comments already on indoor navigation, but we also have like one open for simulation. So if you care about development goals for simulation, please send a message there. But we won't go into these topics. That's going to be part of the developer meeting in 2 weeks. But I just want to let you guys know in case you weren't aware. And of course, you must have seen also on Discord, the ROS discourse, that they started the Open Source Robotics Alliance. So there's going to be some changes in governance. I will just leave the details all to those as well. That means is that we're like no longer a ROS community working group, but we're just a community group or something like that. So that is kind of like, at least that's the term that they want to use internally to refer to us. So to make it easier, we're a community group, no longer a community working group. But in practice, I've asked them, nothing will change. In terms of like, let's say, influence, like because we're a community work group, we never really had influence in terms of as a group directly to the governments of open robotics. However, it is always that you have an influence as an individual by contributing to the code base, and it's hopefully something that we can, let's say, provide as, or at least like try to orientate now with everybody here with the same interest. But let's talk about that at the developer meeting next time. So we're going to have the presentation by Rhys about Gazebo and Aerial Vehicles. So I'm going to stop sharing my screen, and I will give the floor to Rhys. You can share your slides.
Right, thanks, Kim. Let me just see if I can bring these up. Okay. And how's that looking? Can we see the? Great.
Yeah, it looks good.
That looks perfect.
Okay. So this is just it's really just a review, and it's going to be pretty heavily slanted towards using Gazebo with ArduPilot, because that's where I do most of the work. There's a little bit on PX4, and an overview of other things as well. So please excuse the bias, but that's just I think it's better to talk about what I know as opposed to what I don't know, and we can certainly let others who are more familiar with some of these other flight stacks and their integration with Gazebo talk to those, and very much like people to do that in follow-up talks. Some of the slides in here are reproduced from a presentation I gave at last year's ArduPilot conference. So apologies to anyone who attended that and may have seen some of them before, but I think they're quite useful for this review as well. So the kind of outliners, we'll have a look at sort of Gazebo's capabilities, and then there's a couple of projects, and there may be more, so please accept any apologies for if your project uses Gazebo and I've missed it out, then nothing meant by that. This is what I'm aware of. But there's a couple of projects by OSRF that have used Gazebo and the native support for plugins and aerial vehicles within the Gazebo packages. And then there's a few flight stacks that have CITL frameworks that work with Gazebo, and we'll have a look at them and cover some of the vehicles that we've got, some of the extensions that have been made, and just generally a review. So this is mostly a show and tell of what's there, hopefully to kickstart some ideas about where perhaps we can look at some collaboration between the various flight stacks and common development. So this is really just to get the simulation program on the way. So Gazebo has two major versions, I would say. There's the Gazebo Classic, which some people are still using. So it runs up to version 11. It's end of life in 2025. And quite a lot of work had been done for aerial vehicles in the previous versions of Gazebo. I'm not going to be talking about that. I'm going to be looking at the new version, which sort of had various names. So under the Fortress, it was called Ignition. It's now back to Gazebo. The current version is Harmonic, although most of the work we'll be looking at is in Gazebo Garden, but both Garden and Harmonic are available. It's a toolbox really of simulation libraries. It's got a good physics engine with Dart and a plugin system, so you can plug an entire physics backend. For aerial vehicles, we'll probably not be doing that. We'll be looking at writing system extensions. So the main simulation environment is for a rigid body system, and I don't think we'll be replacing that unless you're looking at replacing the entire coordinate system. For rendering, it uses Ogre Next or Ogre 2. It's quite a powerful rendering engine. It's fairly tricky to use under the hood. Fortunately, you don't have to do too much of that unless you're writing rendering plugins. But it allows you to do physically based rendering and have much better lighting. But it does require a more powerful graphics card and a more powerful CPU to run. So some of the simulations that you might be used to running on old hardware are going to struggle under Gazebo Garden with all the rendering switched on. There's a rich camera system. You can extend sensor plugins. One of the really big improvements that they've made in Gazebo is the ability to add sensors. It used to be quite difficult to add them in if you were a third-party writer. It's much easier to do now. Simulation engine can be extended with system plugins. So everything is really a system now or a sensor, and it tends not to differentiate between models and joints and all the other bits and pieces. So it's more uniform, a bit more abstract in order to achieve that, and look at that a little bit more. You can also write custom widgets for the GUI as plugins. These are Qt widgets, and so if you've got an environment manager or something like that, you can do that. Integration with ROS and ROS 2 is provided by a project called ROS GZ, and that allows you to bridge between the Gazebo messaging system, which I think is MQ underneath it all, and uses what does it use? Proto buffers into the ROS messaging systems. Okay, so just looking at if you're looking to move from one platform to the other, so Gazebo Classic was a fairly monolithic application, and you would run it with Gazebo and then the world name and then .world files. They're SDF files, but the naming has changed. In Gazebo Garden, which is sort of GZSim7, is the repo which sort of pulls it all together as a simulator. Is collections of libraries and plugins, so it's much more modular. So there's lots of repos, lots of different moving parts. It's a little bit harder to get your head around, but I think it's easier for the developers to maintain and roll out the various pieces in them. The plugins have kind of changed a little bit. So you'd have like a model plugin, which would have an on update method. And the new one, it's kind of looking at they're all called systems, and they have a pre-update and post-update, so you can control whether you get everything set up before the physics update or whether you analyze the results after the physics update if you're looking at sensors and things. And probably the main change is that Gazebo Sim uses something called an entity component system, which is really just like integers labeling objects, and you attach various properties to them. It's quite complicated to use initially. It's very powerful in that everything is at some level treated on the same level. So the object model, as far as the simulation is concerned, is just lots of IDs with various features that get added, and the features basically add the ability to attach types of data to those objects, which then gets calculated during the update steps. I believe that this is a technique that has been borrowed from game development and allows the simulation to scale quite well. In the models and worlds, the materials for more complicated rendering was managed using Ogre scripts. They've been deprecated, and it now uses the Ogre Next physically based rendering system. So the script materials won't work. And you can write your own rendering scripts as well. That's fairly complicated to do, but you probably don't need to do that most of the time. So the systems in Gazebo Classic would be available automatically, and in the new one, everything is a plugin. So if you wonder why your IMU is not registering, it's probably because you haven't attached the IMU system to the world and things like that. So things tend to work or not work without warning. And so in your world file, you'll see a lot of systems being initialized. So things like broadcasting, the visuals, enabling the physics engine, enabling all the sensors, enabling all custom sensors. These all have to be enabled as plugins. So it's a bit more involved to set up, but again, it makes it much more natural to extend. And once you're familiar with things, it becomes apparent why things aren't working. But there will be a few catches when you start. So things that come on board or out of the box with it. So in the physics, these are relevant to sort of aerial robotics. There are other systems as well for other types of vehicles and things. So in Garden, there's a lift drag plugin, and this has been ported over from the Gazebo Classic, and the advanced lift drag plugin, which I think is used by PX4, has also been made available. I think it's only in Harmonic. I don't know if it's been backported to Garden. There are various controllers for joints. So you can either velocity or position control joints. And in addition to that, there's some more custom controllers for a multi-copter control, which I think is used in the OSRF projects. Not so much by the flight controllers, where the actual like say ArduPilot or PX4 or Betaflight would provide the actual copter control. There's a motor model, which is a port of the Rotor S motor model, originally developed for Gazebo Classic. Then there are things that publish the state, so states of joints, odometry or pose. They get pushed out onto the messaging framework. There's a bunch of sensors for air pressure, speed, altimeters, a load of cameras, which gets extended, and there are things I haven't included in there, such as segmentation or logical cameras. There's an inertial measurement unit, there's LiDAR scanners, these are all GPU enabled, magnetometers, NavSat sensors and thermal sensors. And then the global systems, which I mentioned before, things like physics and sensors need to be enabled at the top level in the world, so that all the features that such as like without a physics system in your world, then there will be no physics. So objects will just stay static where they are. There'll be no gravity, there'll be nothing else. And without the sensors, plugins, your cameras can be attached to the models, but they won't render. You won't see anything until you actually enable the global systems to do that. There are some limited environmental effects. There's a wind effects plugin. I think that's something that would be good to extend further, but there's kind of limited ability to provide environmental effects, but not highly customizable at the moment. So projects that use Gazebo and have been developed by OSRF. So this MBZ IRC was a big maritime challenge simulator. It's quite a nice project. It includes both terrestrial and maritime environments, supports multiple aerial and surface vehicles, water vehicles. And there's a range of vehicles offered, aerial vehicles. There's a fixed wing vehicle, which is, I think, based on the Zephyr, a quadrotor and a hexarotor. One thing that's quite nice is that the SDF models are templated using embedded Ruby, and that allows configurable slots for payloads. Now, this is something that's in this project only, hasn't really been pushed up higher into Gazebo, but it's quite nice because, and you'll see as we look at other vehicle types, one of the problems you have is that if you want to run multiple vehicles or you want to add a sensor to a vehicle, you can wind up having to replicate quite a lot. There's no equivalent to the Exacro for SD format, and Gazebo uses SD format directly. So if you want to template your XML files for loading worlds and putting models, there isn't really a standard way of doing that that's available built into the system. But extension libraries such as these use templating either with embedded Ruby or sometimes embedded Python in order to parameterize the models and then have the files generated on the fly before they're launched. And that's something that may be worth as a stream for the simulation program. The multi-rotors are controlled using a twist, velocity controlled using twist, and the fixed wing UAV is controlled using a combination of MAVROS messages, one for the takeoff and one for the attitude target. I think the vehicle control is fairly simple. I think the main purpose of this was not to model aerial vehicles. It was really to carry out kind of more search and location of various objects on the boats and then report back. So the controllers used in this are not the controllers that you would use on real vehicles, I don't think. And I think it's one of the big differences. It doesn't appear to be actively maintained since it was developed for the challenge. So the last PR is in September 2022. So I think it's interesting as a project. It's got some nice ideas in there, but I don't think it's an ongoing concern. I'll be happy to be corrected on that, but that's just from what I can see in the repos. The next one is the vehicle gateway, and there was a talk about this given last year in the Gazebo community meetings. Again, I think this is fairly probably the last PR from the project owners was May last year. And there's some ongoing community support, but not a great deal. So I think as an idea, it's quite nice. I think practically, it's possibly not an ongoing concern. Again, if the code owners are happy to correct me on that, I'd be happy to update this. It was intended as a sort of a way of consolidating interfaces into a number of different vehicle SDKs. In particular, it started with Betaflight and PX4. So it does a number of things. It manages to download and build the autopilot stacks. It provides Python and C++ bindings. The platform it targets is really just Ubuntu. It won't build on Mac OS. It's tied to Gazebo Garden fairly tightly. It does use Xeno for messaging, which is quite interesting because that's something that actually be looking at using for real vehicles. So it needs to have the ROS framework installed. So the setup works on Ubuntu quite well. I haven't managed to get it running for Betaflight. It runs up, but I'm not getting the vehicles don't tend to respond. I don't intend to try and debug and get it all working, but it has got some nice ideas in there. One of the challenges in putting together a framework like this is arriving at a common interface for vehicle modes and commands. So each flight stack has its own interpretation of what loiter might be, or how you map from the various vehicle modes to integers. And it even varies between vehicle type in a flight stack. So for example, in ArduPilot, the flight modes for copter and plane and the modes for rover are all different. So coming up with a single set of modes that works for everybody is possibly impossible, very unlikely. So you need to probably not do that and have some method of having at least one step away from that. It doesn't include ArduPilot, and it's probably because of license compatibility. ArduPilot's GPL. So if you want to pull in a whole lot of binaries and build the stack, you probably need to be consistent with all the licenses. So that also makes it difficult to use this approach if you want to extend it more broadly. And again, cross-platform support is focused on Ubuntu. That's no surprise, really. Mac OS is not a tier 1 supported platform, but is available and used for a number of the flight stacks. So both PX4 and ArduPilot will run and build on Mac OS, as will Gazebo. So as I mentioned earlier, Project Momentum, I think it seems to have slowed down. Doesn't seem to be actively developed, but again, some ideas in there. So looking at it, some of the useful ideas is perhaps a more loosely coupled message-oriented interop model may be more sustainable. Looking at projects like this to try and understand why they lose momentum is often quite useful to do when trying to figure out how we should direct our own simulation efforts. Okay, so now starting to look at, so the next sections will be really just looking at kind of flight stacks, sort of autopilot stacks, simulation in the loop, and their integration with Gazebo. So the argument here is that if you're looking to do, it's going to be very noisy here because it's raining like anything. I'm in Wales and it rains a lot. So Betaflight has integration with Gazebo. However, it appears from the documentation to mainly target Gazebo Classic. It uses a binary protocol, very similar to the way that ArduPilot Gazebo plugin does. It's a kind of a bidirectional socket, and it has a couple of structs defined, one to carry the PWMs from the flight controller to the simulation, and then return some flight dynamics information that the controller needs to do its processing, basically pose, orientation, and a few other things. The vehicle gateway, which I mentioned earlier, does offer support for Gazebo Garden and ROS2 Humble. And the most recent PR to Betaflight for Gazebo support in February last year kind of added that support. But I don't get the sense that the Gazebo is actively used with Betaflight. And if there were Betaflight users who are interested in doing that, then that's perhaps something we could look at further. So that leaves the other two kind of flight controllers we'll be looking at here, which is PX4 and ArduPilot. Now, I mainly work with ArduPilot. I've used PX4 a little bit, so I'd be very happy, as I mentioned earlier, for someone to provide a much more in-depth guide to how PX4 works. So this is an overview that I've got by some of the work I've done with terrain navigation and just going through the PX4 Gazebo integration code at a high level. It's very nice. One of the things that the PX4 does very well, it's very easy to launch Gazebo and the models it supports. And the approach is quite nice. It's different to the way ArduPilot does it, and we'll look at that in a little bit. So there's the user guide's all online, and if someone wants to, you want to find out more about it, then I'd recommend going through that and working through that in detail. Supports both Ubuntu and macOS. I run the simulations on macOS, so I can confirm that that all works. And one of the big differences is that it uses the Gazebo transport layer directly. So there's no need for a custom plugin, like a PX4 plugin or a Mavlink plugin on the model itself. And that's quite nice, because it means that the plugins are, in that sense, models in that sense are a kind of autopilot stack agnostic, and that's a good thing. There's models, and that lets you load the models up to the Gazebo Sim app. Sort of, I think it used to be called Fuel Tools, and that's a community repository of models that have been put together by organizations or individuals. And there's a repo, GitHub repo for the models as well. The vehicles offered, there's a variety of aerial vehicles, omnicopters, multi-rotors, so PX4 Vision, and the X500. There's a couple of planes. There's a standard Cessna, which is configured, I think, to use both the standard lift drag plugins, and I think there's a variant which uses the advanced lift drag plugin. There's a Skywalker X8 configured as a standard VTOL, and then the X500 has a couple of variants which have sensor payloads, different sensor payloads. So the models use all the package Gazebo systems and sensors. So there aren't a set of custom plugins. So with Gazebo Classic, PX4 maintained a set of custom plugins to manage sensors, manage the kind of socket integration with CIDL, and so on. Now these things are all available when you install Gazebo with all the core packages. So these include lift drag, position controllers, the motor model, sensors for air pressure, various cameras, the IMU, and in some cases they publish odometry. I think that's for sort of visual servoing and that type of thing. Okay, and please come, I can't quite see the thing. If anyone's got any questions, please feel free to interrupt, or we can answer them at the end and come back, however you prefer. Okay, so my main interaction with PX4 and Gazebo has been on some of the work we've been doing on another one of the streams, on the terrain planning stream, where we're looking at porting Jay's terrain planner from ROS 1 to ROS 2. And in this, this was really just to test the end-to-end integration. PX4 has a nice controller, the nonlinear path following guidance controller, which was designed to work with the terrain planner set points that were coming through. And so that was a good first point to check that everything integrated well. So here we have a standard VTOL frame. There's a terrain model, which we'll talk about how we generated that a little bit later on in the talk. Ground station is just QGC. The set points in this example are coming in via MavROS. So PX4 does have DDS support as well, but this particular example is not using that. That would be, I think, a target state for how the terrain planner would integrate with flight controllers, is to use ROS directly via DDS. But that's not the case here. And then visualization and others. So this is a nice example. It's the whole package where you've got offboard control, you've got your simulation, which is mainly here. It's used if you fly into the ground, you know, you'll know about it because there's a collision mesh sitting underneath the terrain, and the vehicle hits it, it stops. And you get everything. So it's gazebo simulation, flight control for all the dynamics and the bits that you want to flight control the floor, and offboard planning. And what's nice is that most of this is transferable over to the real vehicle. And I think that's one of the things you're looking at for in the target state is, and one of the reasons that I'm focusing probably so much on using like autopilot stacks as the flight controllers is that we really want to be using the autopilot flight control stacks if we intend to use those in rear vehicles, and that we get the simulation to do the stuff that we can't do, such as the physics, and maybe the visualization and other bits and pieces. But I don't have a great interest in providing flight controller logic in the simulation, outside of running a flight controller's core software in Linux, which is doing that. And that's a good setup. So you kind of get the bit of software designed to solve the problem, solving the problem, and you sort of augment with Gazebo the bits that flight controller is not doing, and that's sort of having the right software in the right place. So that's kind of that's the other flight controllers covered here, and we'll be now moving into sort of ArduPilot. So this is where the kind of bulk of the work I've done with Gazebo and Aerial Vehicles has been adding kind of sort of support for more vehicles, and kind of additional features in ArduPilot sort of, starting with the port of the plugins over to use the new Gazebo frameworks, and then adding functionality in response to some of the sort of requirements of various devs or some of the users that we get on our discourse channels. So we'll go through some of the vehicles that we've provided, looking at getting terrain, some features that are quite nice, like such as lockstep simulation, and then to end, a couple of examples where we've had kind of requests from the partner programs or part of our GSOC work where we've kind of integrate everything together, and use the vehicles that we've got. Okay, so vehicles. Bicopter to start with. So this is really like, this part of the talk is really just like a show and tell, if you like, of what's available. So simple little vehicle, 2 servos, 2 motors, really sensitive to center of mass positioning and really prone to oscillations in the tune. So quite a careful rate tunes required. Otherwise, if the servos are really prone to oscillate in this. Quite similar in many ways to another vehicle we'll look at later, which is like a tilt rotor, but here you don't have any control surfaces. So we had a user on ArduPilot Discourse who was looking to build one of these, wanted some help getting his simulation working, and so we kind of did some work with them. It was quite interesting because we didn't have this particular vehicle covered. So you need to be pretty careful with the way that you rig the model so that everything is in the right place. Try and get the inertial and physics properties as correct as you can, and then and then the rest of it will be dealt with the tune in the flight controller stacks parameters. Okay, this is another VTOL. So this is a Mini Hawk, which is a 3D printed plane. I have built one of these, so I wanted to have the simulation model to test how this vehicle was going to behave before I put my own vehicle into the air. Kind of one of the main things with VTOLs is you often have trouble with kind of yaw control on them. In this case, these tilt rotors are really prone to your oscillations initially. So the standard VTOLs, where you don't have tilt rotors, you just might have 4 lifting motors, they're often yaw under actuated, because you're really only getting yaw through the drag from the motors or from the props. So you're relying on the torque from that to do your yaw. On these ones, the motors can tilt forward and backwards to provide you with yaw control. And one thing we're observing is that you would wind up with oscillations, and that's mainly because the rate controllers need to be dialed back quite a lot for these, and you have to tinker around with the things like the angle which you let those rotate through while they're in VTOL mode. So quite a useful environment to set up. I think real flight probably has, well, not probably, will have better dynamics for that, but for the VTOL study, this was good enough. So yeah, like a tilt motor tricopter. So the rear motor is pitched forward but doesn't actuate. Okay, so this is the vehicle that in some ways is similar to the bicopter. Again, prone to oscillations, as we can see over on the right hand side before it's tuned properly. It can be unstable, and so you can tune these out, but out of the box they don't necessarily behave very well. So this is a vehicle that sits on its belly, the rotors tilt up, it has a vertical takeoff, it hauls itself into the air, and then once it's airborne it transitions into forward flight. So again, quite nice to have that. Again, it enables you to study some of the properties, mostly a qualitative description. You're not going to be able to transfer the PIDs for the rate controllers directly over from the simulating vehicle to a real vehicle. The physics isn't captured well enough to be able to do that, but it does give you an idea of where to look, and you can have it really helps moving to a real vehicle to have some idea of the behavior in the simulated vehicle before transferring over. So an H-wing, this is a vehicle with no moving control surfaces, actually really difficult to tune in simulation. Maybe in other simulations it's easier. In Gazebo it turned out to be quite difficult. All the yaw and pitch authority comes from the canting of the motors outwards and slightly inwards towards the wings. I can't remember which way. It's either outwards or inwards through the wings. And also very center of gravity dependent. So in vertical flight, it's no problem at all. The difficulty comes in the transition into forward flight and getting the pitch attitude correct and making it work. So it's another vehicle where the structure of the vehicle raises some challenges when trying to simulate it, given all the limitations of the aerodynamics model that we've got. So the various round markers that you can see on the right are either contacts or helping to visualize where the center of pressure for the lift and drag has been placed, or center of mass. So again, all the models are quite sensitive to where these are put. So getting that right is one of the processes involved in setting up the models. Okay, this is a really interesting aircraft that was put together by a group of Canadians, and it's a community contributed. So it's a weight shift controlled aircraft. They have a real vehicle, so full-size hang glider type size of vehicle that uses this weight shift control principle. They wanted to test all of their control systems out using simulation before they ran it on the real vehicle. So they've spent quite a lot of time configuring the model to have good aerodynamics properties good enough to match the vehicle that they actually have. And it works very nicely. In the end, the control system is just adapted using a standard RG plane controllers. It doesn't need a custom controller. Most of it is all around the setup of the hang block and the way that's actuated. And there's a link there to the company and their the paper on this particular model. So that was quite a nice to have, having sort of someone from the community add back into that. This is a full-size model of a sailplane. We kind of had again like a discourse request for more fixed wing type aircraft. So it's capable of powered takeoff. So here it's a sailplane, so its lift drag coefficients are quite different to like the other planes and vehicles we've got. So the way that the lift drag plugin and Gazebo is set up, you've really got it's piecewise linear approximations to the lift drag curve. So you don't have a lot to play around with. It's got a very sharp transition at the stall point. And so, you know, there's lots of problems with that. But given that that's the model, how do you go about fitting a lift drag coefficients for your particular aircraft? So you have to choose a Reynolds number for the aircraft, and then on airfoilstools.com you can look up an airfoil which is a good match or an exact match for the airfoil that comes that's with the plane. So the foil profiles for this particular sailplane are available in its flight manual. They are available in Airfoil's tool. And so once you have the lift and drag profiles, you can just try and fit the lift drag model to them. And it's not too bad. It's not great either, but it's good enough for a vehicle to have reasonable properties. So the process of doing this for a new vehicle is similar. So there's a piece of work to do. Again, it would be nice to have all of this automated, where you had a database of the profiles you could fit to, but we don't have that, and it may be better to have a more precise lift drag model in any case. Okay, right. So terrain, there's a couple of tutorials for developing terrain models. One for Gazebo Classic and one for the newer one. It's actually in the rendering kind of tutorial section. So you have to dig around to find it a little bit. Here we take a slightly different approach. So we needed a terrain model for the terrain planning example provided earlier for PX4. The way that we put that together is that we use this city skyline height map generator. It's quite nice, it's a free online tool. You basically select an area. So if you want good resolution, you select the smallest map size, which gives you a 17-kilometer square area. You kind of dial in a couple of the settings, and then you download the height map and the texture for that. And then you can create a terrain model using the height map. So the main things are just to get the size correct. So you want to set the size of the tile for the height map to be the same as the tile we downloaded. You need to make sure that the elevation is equal to the difference between the lowest and highest point on the terrain map. And then there's a little bit of fiddling around to get the actual overall position and height matched up properly, because if you want the aircraft to be centered at a certain point, you need to make sure that that particular point is at the right elevation, and that requires a little bit of tuning. It'd be nice to have that automated, but the end result is very good. You wind up with quite a reasonable terrain map that does align quite well with the data and the terrain map we used in the terrain planner. So that's something to extend. Okay. Right, let's move on. So one of the things we put in place in ArduPilot was the ability to lockstep the simulation. That's really invaluable for debugging. You want to be able to either stop the simulation in Gazebo. So if you've written a physics plugin and you want to check it, you need to be able to put a breakpoint on and stop that, and then you have the flight controller also stop, or vice versa. So if you put a breakpoint in your flight controller code, you want the simulation to stop, so you can step through it. And the way this works is that you just have the socket, either side of the socket, the plugin on the model, and this sort of the API. In the case of ArduPilot, this is the JSON CIDL API. Both wait for the next message to come, and if the message doesn't come, it just sits there waiting. So that allows you to stop the simulation at either end, and that's proved to be extremely useful when trying to trace problems, either in your custom plugins or in the controllers as well. So this was really just a toy. One of the devs was thinking about attaching some rotors to a hexacopter, a hexapod. We thought, well, we can simulate that, but what we needed to do is, because the particular model for this is Lua scripted, so the way that the robot unfolds its legs is a script that is running using the Lua backend in ArduPilot, and you need extra servo support. So we extended the range of servos in our plugins to be 32 rather than 16 to support that. And just a little bit of history on how that was put together. Parachutes. So someone wanted a parachute. Gazebo Classic simulations had parachutes, so we ported that plugin over. And then quite often we get requests for gimbals, and so we had like a 1 or 2 axis gimbal. We've extended that to 3 axes. It just uses, rather than having a custom plugin for it now, we just use the joint position controllers. And the way ArduPilot deals with it is because we don't, the ArduPilot flight control stack does not talk to the GZ messaging layer directly. We just then forward the commands on the plugin on the model. So there's an option now to be able to do that. So another thing we added with the gimbals was the ability to zoom the camera. So this is, again, the flexibility of the new Gazebo plugin system is demonstrated here. You can attach plugins to almost anything you can imagine. So in this case, it's a camera sensor. So there's a plugin that attaches to that, and then just fiddles around with the field of view inside the camera plugin by overriding some of the properties in that. So Ryan extended that by adding a slew rate control. So we've got sort of 3-axis gimbals with zoom on them as well. So that's quite a nice add. And the gimbal with the zoom camera can be attached to any of the models you like. Okay, so then applications where all of this has been put together. So one of our developers was working on a script to manage takeoff and landing of quad planes on moving platforms. So they had they were running this in sort of the normal CIDL with MAV proxy, which is really a 2D system. They wanted to have a 3D view of it just to check that and be able to talk through with some of the partners about how it was going to work. So here we have quite a large quad plane landing on the back of a large research vessel. And that was, so there's quite a lot going on in the simulation. There's multiple vehicles, there's custom environments. The ship is sitting on an ocean simulation, so it's moving around in the waves. There's at least 3 GPS beacons kind of all tied in. So Gazebo lets you do quite a lot in that respect, and the other simulation platforms may have better aerodynamics, but they don't have the flexibility to be able to pile all of this stuff into them. So that's where Gazebo starts to shine. We had some nice projects for some of our GSOC students last year. So Ryan, who's on the call, was involved with a student on this. And this was for off-board GPS denied navigation. Really nice project where quite a lot of background work that had been going into the flight controller was all tied together with kind of ROS, DDS support, off-board support, and then a simulation in Gazebo to provide sort of LiDAR feedback so that you could then use the Nav2 stack and cartographer to navigate through a maze. So this is an Iris quadcopter navigating through a maze, and it's the normal RViz thing you can do with a rover. You kind of point and click, set the goal, and it goes to the goal using a velocity controller in the autopilot to fly the thing around in the Nav2 stack to tell it to where to go. So that's all quite nice, and there's more details online if people want to follow up on that. And then the most recent one is, again, one of the devs is involved with some in Australia fire service, and they're looking to be able to use quadcopters to spot small fires and then put them out. So they have a problem where the quadcopter is now carrying a payload, and the payload is of a mass which is of the same order of magnitude as the copter. So that can cause interesting effects for position control, and so they wanted to have a simulation to be able to model that. So here we have a tether which is just made up of a whole heap of short sections of rods with universal joints, and a sphere hanging on the end with a mass which you can configure, and there we go. So application to bushfire control and also magnetic surveys as well. That's another thing that people seem to be using quadcopters for. You hang a large sensor array on the bottom of a long tether with a number of magnetometers and an IMU. So that's another practical application of it. And there we go. So Kim, happy to take any questions.
All right, thanks. That was very interesting. So anybody that wants to ask a question, just raise your hand or open up your mic, or just ask it in the chat. We still have a few minutes to go. All right. Hi, go for it.
Hi, do you hear me?
Yes.
Yes, thank you. So thanks a lot for the presentation. It's really a lot of interesting examples. I was interested in the last example that you showed where you have a tethered payload. Do you have an idea how the tether, the tether itself, the rope, let's call it, how was it modeled?
It's very simple. So it's just there isn't a soft body simulation in Gazebo, so it's just a set of short rigid bodies connected with universal joints. You could probably get some soft body effects or stretch effects by messing around with the parameters that control the joint. So the way most of these rigid body systems manage the joint is that they are managed by a set of constraints, and so you can have spring constants or friction constants within those joints. I haven't done too much with that, so it's a fairly rigid rope from that respect. So it's a set of short sections about 0.2 meters long, joined with 2 revolute joints at each point, and it gives a reasonable qualitative effect, and certainly you can see the effect of the payload on the vehicle. If you wanted to model the rope more accurately, then I think I believe there's work that's been done on other ROS projects and Gazebo projects that does that, like people looking at robots with power cables and things like that. I've seen something there quite nice about better modeling the the cable. Of course, the issue is with the more sections that you have, it's going to be more expensive to simulate. And at present, at least, Gazebo doesn't have a elastic or soft body simulation to be able to switch into. So it's an approximation at best.
Great, thanks a lot.
All right, that was actually also my question. So that this has been answered. Thanks a lot. Ricardo, there is one from Ricardo who's asking, is there support for GPS navigation in the new Gazebo or a GPS navigation plugin? I guess there is.
Yeah. So there is a navsat sensor, and there is an element you can set on the world, which is a spherical coordinate system. So I think in one of the examples back in the slides, and Kim, I can make the slides available if there's a place for sharing them. I'd be happy to do that. Where one of the examples does have the navsat widget up on Gazebo. However, the navsat sensor data is not being fed back into the flight controller. So the flight controller is simulating a navsat sensor based from the ground truth information coming back with the other flight dynamics information. But for most of the simulations you saw, apart from the one about the GPS denied example, which is using nav2, they're all using GPS waypoint navigation. So the flight controllers generally expect the GPS to be present. And so I'd say, yes, it's been simulated, but no, the data for the GPS is not being provided by Gazebo in the examples I showed. I hope that answers the question. So
let's see, Ricardo says he's satisfied with your action.
Okay.
With your answer. And to also answer your question, yes, we can, like if you could send your slides to me by email or Discord, then I can share them on the same Discord thread where I post the recordings and all the documentation of the meeting.
Okay.
So yeah.
I'll do that. Yeah.
So that will be great. Like just a PDF or like a link to the drive is fine.
Yeah, I'll give you a link to the Google Share, and you can take a copy if you want, and put it somewhere. So
yeah, perfect. That will be great. One more question, and then I'm just going to close off for today because we're already over the hour. So Mayank, go for it.
Hey, Rhys. Amazing demos. It was a really fun show and tell. We should do more of these. I had a question. Have you ever come across a system plugin or something in Gazebo for telemetry or communication simulation? Because I think it'll be useful for testing things like fail-safe mode. So either at the physical layer of RSSI, path loss, or maybe at the higher layers for packet loss or range in some fashion. Or have you not seen that in Gazebo at all?
No. I'm not familiar with it. I know that in the MBZ there was a communication that there is a radio communication plugin that comes as part of the Gazebo packages. I've not used it. I don't know whether it can simulate package loss and things like that. So it's a good question. I haven't looked into it. So I'm not sure what the functionality of those plugins is. And it would be worth looking into.
Thank you.
All right. I think it's then best then I'll close the meeting for now. If there's any questions that you have to Rhys, it's better to maybe kind of ask them on a different platform than
yeah. So we've got I think there's a simulation subgroup in Discord now. So
yes, indeed.
Feel free to fire questions through there. And yeah, we're happy to help.
Yes, I've also shared at least. I'll just go ahead and share my the meeting slides now. 1 moment. I've also shared a couple of interesting links. Can I share my screen already? Yes, I can. It's not working for me. Let me just stop the screen sharing and open up again. It's taking a long time. There we go. As I want to say, I've also shared some links to both also a overview of different simulators, including Gazebo, of course, but compared to each other. There's also the landing page to the simulation subcommittee with also the link to this Discord subthread about simulation where you can ask questions to Rhys. But yeah, Rhys was really interesting. It was very nice to see all of those like applications, what is all possible in Gazebo so far. So that was really interesting. Thanks a lot for that. So the next meeting is going to be a developer meeting with the subcommittees, the different subcommittees that we have, to talk a little bit more about development rules and everything like that. So that's going to be on Wednesday, 10th of April. It's 3 p.m. UTC. However, do be in mind that we might change this time because it kind of coincides with some other meetings as well, and people that don't use same UTC. So we might need to change that, but I will set an announcement on Discourse, the ROS Discourse next week, and I will of course post it on Discord with if there's any specific particular time changes. Also, the GitHub organization for this working group is called github.com/ROS-Aerial. So there's also the source for the aerial robotics landscape. Also, you can add yourself as a member, and if you also want to do a presentation like Rhys has done, please send me an email or Ramon an email about that. So thanks a lot for joining this presentation meeting, and I hope to see you all in 2 weeks.
Okay, thanks, Kim. Thanks for hosting.
Yeah, and thank you for the presentation. It was super interesting.
Okay.